super hot, so you don't need to lean into it, and
Okay.
I'll adjust it anyway.
Hi, everybody. Thanks for coming. Can you guys hear us okay? All right, so my name is Victor, and this is Lois, and we're from the NASA Jet Propulsion Laboratory. I lead a lab that focuses more on software and visualization of spacecraft data, and Lois leads more creative design strategy. So we're going to talk a little bit about our work. Feel free to chime in whenever. This is going to be sort of an open forum. And I've got a couple of giveaways. You guys can have some Polaroids and some keyboard stickers. So have at that while we talk about our stuff. So Lois will kick us off, and then I'll talk about some of our VR AR work in a sec.
Hey guys, thanks for coming here. I'm Lois from JPL, and I work in the group called The Studio. And we have 6 other designers besides me. We all come from different backgrounds. I have graphic design, we have illustration, product design, and because of our backgrounds, we're able to work on many different types of projects. These 2 are sort of like the theme of how we run our projects, helping people think through their thinking, sneaking up on learning, and I'll kind of take you guys through some of our projects on how we use this theme. At JPL, we have this area called Left Field, and it's basically a collaboration space with a bunch of sticky notes, whiteboards, Sharpies, and we invite engineers and scientists to come brainstorm with the designers, and we help them visualize what they're talking about, have them get physical with products, make prototypes. We encourage them to draw for us and explain to us what they're really talking about, and this is an area where we ask them a lot of questions to help them understand what they are trying to achieve. A lot of times scientists have a hard time communicating with each other as well. So we, as designers and visual strategists, we kind of come in the middle and kind of help them brainstorm mission formulation. And Jesse Kawada on the screen is actually a core team member of a group called A-Team at JPL, and they run through this study at least once a week. And sometimes you get asked to do not so exciting things. This is an empty hallway in one of our buildings, and we were asked to decorate it. And instead of just decorating the hallway, David Delgado in our team had this amazing idea of wanting to do a travel poster. And do you guys know what exoplanets are? So exoplanet is planets around other stars, similar to our solar system, and we had this idea of what if we create travel posters to exoplanets and kind of create illusion, or actually have people imagine what it's like to travel to that planet one day. And these 3 were the first series that came out, and they weren't supposed to go public, but one of the summer intern took a picture in that hallway where these posters got hung up, and all of a sudden it became viral overnight. This is one of our favorite one. It's a planet with no stars, so how do we make people want to go there? It's a planet where nightlife never ends. So we sat down with scientists, brainstormed on ideas on what can we talk about each planet that's actually real, that we don't convey fake messages. And like I said, overnight, we started getting phone calls from all these networks and companies, and for interviews, phone calls. And these are, what comes out from our studio is all public domain, and they are all on JPL website. Sarah Siegel is a famous exoplanet scientist, and she showed our posters at our TED Talk, and people started using our designs, and products started selling them online. You can buy a flask with their design on it. They're really high res too, so you can print them, print them really large in your house or something. And then our previous director, Dr. Ilachi, went on a vacation with his wife and saw this national park calendar and asked us if we could create a calendar for the lab. So and it was a very short turnaround time, and these are more series of designs that we came up with. We hired a few contractors to work with us on this very short time frame. And this is one of one of our most favorite email that we got of a couple who hasn't had their baby yet, but they're hoping to print out these posters to hang in their nursery room, and we thought that was very funny. And this is a mission control room at JPL, and this is where all the data from spacecrafts come down to, and this is also where we send the data up to those spacecrafts. And Dan Goods, you see on the screen, had this idea of somehow visualizing data coming down to us and going up. So right now you're seeing a prototype, early prototype of the sculpture piece called the Pulse. So you'll see in the middle pillar, you'll see a spacecraft's name either come down or go up. For example, Voyager 1, which has left our solar system, you would see it go up, so that means we're sending the data up to the Voyager. The amount of light that's coming down is the amount of data we're receiving currently from Voyager, and the amount of light going up shows the amount of data we're sending. So this was one way for us to help people visualize how much data we're constantly receiving from these spacecrafts. And what you see on the right is a smaller version of the Pulse that we made to give to Dr. Ilachi when he retired last year. This is one of our recent installation. It's called the Orbit Pavilion. It was created last year at the World Science Festival that was in New York, and now it's currently at the Huntington Garden. Basically, it's a giant seashell, and the idea is if you go to the beach and you pick up a seashell and you put it to your ear, you hear the sound of the ocean. And the idea for this is when you walk into this giant seashell, you hear the sound of space. Basically, there's 50 different speakers all around, and they're all connected to spacecrafts that are currently orbiting the Earth and studying the Earth. These are spacecrafts that are studying our oceans, our lands, atmosphere, whatnot. And depending on what these spacecrafts are studying, they have different sound to it. So we worked with a sound designer and also an architect to build this beautiful shell for us. And when you go in, you kind of sit down, close your eyes, listen to all these sounds go by you. So if you hear a sound traveling from left to right, it's actually tracking the spacecraft that's flying over you. So it's to help you feel like you're surrounded by all these spacecrafts, but also to let people know, let the public know that NASA is not only doing space exploration, but it's also studying a lot of Earth. And this is also our way of sneaking up on learning, is that we're not just throwing out information to people. We want to bring them in and have them be interested in what it is, and then kind of tell them, hey, this is what NASA's up to. This is one of the current projects that I'm leading. It's similar to the Orbit Pavilion, but it's basically an interactive street sign. It's currently at prototyping stage right now, but what you will eventually see on the screen is either a planet's name or exoplanet or even ISS, and depending on what you want to see, it'll appear on the screen, and the sign will move to where the position's at. And hopefully it'll give more information on how hot is it in that planet, how far is it, how long does it take to get there. Another way for people to kind of be more engaged in what NASA is up to. And the idea is that this will be at JPL sometime this year. And by the way, that's being fast forwarded, so it's not really moving that fast. But the idea is maybe this will kind of go around in public spaces as well, maybe in Joshua Tree, where people actually go look up in the sky and see the stars, and they can actually see what they are. And I'm going to play a little video for us after this. It's called, have you guys heard of Juno mission? It just recently happened last year, 4th of July. We launched a spacecraft called Juno to Jupiter a long time ago, and before getting to Jupiter, it had to come back to Earth for a flyby, and it was our last chance to speak to it. So we did a special project for Juno, and I'll play that video.
This is my transmitter. Maybe it's something you can use, I don't know.
Juno experiment is something that a group of us came up with.
The biggest challenge we had was we didn't know if this was going to work or not.
If it works, I'm part of history.
This is W6JPL, Jet Propulsion Laboratory in Pasadena, California. Hello, CQ, CQ, CQ.
The Earth flyby is Juno's way of gaining some extra speed and changing direction so that its orbit can take it to Jupiter.
We said, what if we actually sent something to Juno? Basically came up with the idea that we could send Morse code to Juno, enlist the support of amateur radio operators around the world.
So the intent is to join amateur radio community together in a coordinated transmission from Earth to the Juno spacecraft as it flies by.
The website would tell them, okay, key down now, then key up, transmit for 30 seconds. And that's how we would send a DIT. Everybody knows Morse code is dit, 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 da, da. Well, it turns out to say hi to Juno, it takes 4 DITs, in space, and then 2 DITs for the eye.
I thought, wow, that's a neat thing to do, and they're going to need a lot of people to pull this thing off. I said, I'm good to go.
We're getting ready right now. Here we go.
And now we are transmitting here.
They could hear ham radio operators all over the world doing this, which was really remarkable.
Everybody's doing this at the same time. Thousands and thousands of hams.
With any luck, the Juno spacecraft will be able to listen and hear all these amateur radio transmissions.
And so what we're doing now is we're looking at the data that's come down to see if we can put together that signal that says, hi.
Will it work? Who knows?
I have the audio from Juno. I'd love you to listen to it.
Come on. This is it.
This sounds very cool.
Actually worked and it heard us.
When you think about what it is, it was really, really amazing.
How many times do you get to say hi to a spacecraft that's made by your planet?
To be a part of it, that was very great.
More than thinking about what it means to me, I think it's just such a great thing that humankind has the ability to think beyond our own environment. It's the curiosity, it's the adventuring spirit, I think, that the space program has given us.
Hi, Juno!
Hi, Juno.
Hi, Juno.
Hi, Juno.
Hi, Juno.
Hi, Juno. Goodbye, thank you.
Okay, take 17.
That's it for my presentation. Thank you, guys.
You guys have any questions for Lois or her design studio?
No?
While I set up? Yeah.
So, what is a typical day in the studio? Do you work with engineers and scientists every day, or do you mostly work on your own?
I would like to work on my own. Sometimes my day is just packed with meetings, answering phone calls, and making sure the projects are moving yeah, a lot of days are filled with meetings, client meetings, and also talking with fabricators, because we do conceptual and design work, and none of us really have fabricating skills, so we work with a lot of contractors, so working with them And we have our little collaborative space, so we also brainstorm a lot with each other. Yeah.
Yeah.
My background, I studied graphic design at Art Center, and Art Center is actually minutes away from JPL. And within graphic design, I focused more on motion graphics. And I've always knew I wanted to do more than just graphic design and more than just motion graphics. And JPL, the studio, actually did a lot more to it. So not only do we just do plain graphic design, poster design, things like that, but we also do a lot of outside thinking, a lot of physical installation buildings and conceptual projects, and I was really fascinated by that. And by the time I was graduating, somehow luckily got transitioned into the team. So ever since, it's been about 3 years, and I've been fortunate enough to work on many different variety types of work there. Yeah. Thanks. I think you can go.
Is there another question, Casey?
Oh, yeah? Oh, okay.
All right. My name is Victor. I lead the Ops Lab, which is a software and design lab focused on building applications for controlling robots and spacecraft. So here's a quick video of some of the work that we've been doing. Turn this down. Okay. So we've done a lot of work, with commercial companies, working with game interfaces, natural user interfaces, and more recently in virtual and augmented reality. And so in doing so, we were able to work on a lot of robotics applications, a lot of Mars applications, just really exploring what's capable, what's out there, right? What are things we can leverage from the commercial industry to help our operators, help our scientists, help our engineers, and help our astronauts? And it's sort of an open question. It's an ongoing challenge to try to find the best tools to solve some of our toughest challenges. We've gotten to work with a lot of commercial companies, got to work with a lot of agencies across NASA, people from the Flights Command Center in Houston, launch centers in KSC, and just really all over. It kind of started our VR work started with the Oculus Rift. So in VR, Oculus, it was kind of the first device that came out 4 or 5 years ago. Back then, they didn't have very good tracking, right? You had to sit there and use the device. You couldn't move around in an environment. There was no room tracking. And so we built our own rig. We built this whole room, which was our VR room. We kind of wired all these cables up, and we were able to attach this funky rig on top of our headset. And so you could actually walk around in a small subset, a piece of Mars that we built. So with that information, we sort of built this initial experience of what it would be like to explore Mars from the comforts of your home. Because you see, our scientists, they're primarily geologists, right? So the way they explore a place is they go out to that place. They'll go study that outcrop. They pick up a rock. They go have their collaborators together. But when we tell them to study at Mars, they don't have any of those tools, right? So we take away all of those intuitions, and we just give them sort of this display of images. And that could be really sort of intimidating at times and really confusing at times to understand how far things are, how large things are, and of course, how to plan for the next day. So we did a quick study using some of the data that we had collected. We built a small piece of Mars in this VR experience that I talked about. And then we did a little test to see if they could understand where they were on Mars effectively. And what you see with that graph right there is essentially that they were able to pick out targets much more effectively in this immersive experience, be able to understand where they were, where the rover was, and where everything else was. And with that little piece of information, we kind of knew we were on the right track. So we started doing more research, working with more partners. So things like Project Morpheus, which is now Sony VR. And we expanded on our Mars terrain, made it better, made it more visually appealing. And let's see here. You can see we got the terrain to be a little bit more improved. And then we decided to even go a step further and work with the more recently announced Microsoft HoloLens. So HoloLens is a little bit different. It's an augmented reality device. So virtual reality, it blocks out your view and replaces it with something completely different. Whereas with augmented reality, it's sort of adding additional assets and things and creations into your world. And we thought this was sort of the best mix of all these traits, of these technologies, and it allows our scientists, who are not technologists, they're not gamers, it allows them to easily explore these kind of distant worlds. So together with Microsoft, we built this first experience called On-Site, where essentially we brought our scientists to Mars from their offices, or brought Mars to their offices. So essentially what happens is they're able to join these sessions with other scientists and explore Mars and do science together. And their other colleagues show up as these avatars, and they're able to see Mars in a way that they can never be seen before. And we've improved a lot on our terrain, and this is actually what it looks like now. This is what Mars looks like, and everything you see in here is 100% accurate, right? None of this is CG, there's no post-processing, there's no artist in the loop. Every pixel you see in that image can be traced back to a series of raw images from either the rover or the satellites that revolve around Mars. And so ostensibly, we created the best visualization, 3D visualization of Mars so far. And then we drop that into the HoloLens, and we have our scientists be able to walk on Mars every day. So that's sort of our first experience, which really touched on how can we help our scientists do better work, right? And from there, we started a bunch of other collaborations. We actually did a spin-off, which is called Destination Mars. And you can see in here, we took Buzz Aldrin, we captured him holographically, and you're able to visit 3 sites on Mars with Buzz Aldrin. So this is the same data set as the scientists used, but we wanted to show off sort of the beautiful terrain and make sure that it was more interactive for people all across. So we deployed this at Kennedy Space Center in Florida, and we had about 25,000 people go through it in 3 months. So that's a really interesting experience of how to deploy a location-based mixed reality experience, which has kind of never really been done before. Here's
Welcome to Destination Mars. Get ready to walk on the surface.
I'll skip that. Then we thought, hey, if we can help our scientists, what about our astronauts, right? And so this is Scott Kelly on board the space station. When he went to, do that year in space last year, we decided we could help him do their work better. So the problem with the space station is, any given time there's about 3 to 6 people. And these 3 to 6 people are expected to do everything to maintain the onboard, this most complicated system that we've ever built, right, the space station. They gotta do all these procedures, they gotta make sure that the space station's flying, they have to make sure they're doing all the science. And it's very hard for these people to remember all of these procedures. So we thought we could empower the way they do their work by giving them guidance from the ground, remote guidance. And so what you see in the picture is you have someone on mission control. They can see what the astronaut is doing and in real time assist. Put things in their world, right? So put images, diagrams, annotations, models. Imagine the procedure acting itself out as you're building it, right? It's incredibly powerful. And so we launched this a year ago to the space station. We checked it out on board while Scott Kelly was there, and it was a really exciting experience to work with these really talented folks.
On the space station, we're
And
the
here's
scientists,
something
we're the
else.
plumber, the electrician, the doctor, the IT guy. We have to fill all these roles.
Do you say you can see us? Or
Oh my God.
The person on the ground could be drawing things in your field of view and pointing to things, and I could be doing the same thing. I was pretty amazed at how seamlessly it worked with their system on board the space station, and was very impressed with what will in the future be its ability to help us do our work. On the space station, you know, we're the scientists, we're the plumber, the electrician, the doctor, the IT guy. We have to fill all these roles.
Did you say you can see us? Or not?
Oh my God.
There it is.
Okay.
There we go.
Sorry about that. Okay. So last project I want to talk about real quick is protospace. Protospace is essentially, you can think about it like Tony Stark, Iron Man, being able to visualize spacecraft, CAD level designs at any space in any scale. Anyone who puts on this device, runs that application, can load up these extremely high fidelity models. So some of the models we've been able to load in, like for example, the next Mars rover, are up to 60 million polygons. So even on a powerful desktop machine, that lurches, right? There's loading that model. And so we were able to build a pipeline to automatically decimate that into something that's viewable in a portable device like the HoloLens. And so we've been able to build this, and we're bringing in all of these missions that haven't been built yet. And so these mechanical engineers, these designers, these reviewers, these mission managers are able to sort of plan out this entire assembly facilities, designing components of it, visualizing physical components with the larger context of what they're building. And this is incredibly useful, and I think really powerful in a lot of other industries as well. So exciting stuff here. I'll show a quick video of how it works. But essentially, you know, you've got the model, people are seeing it. It looks like it's there. I wish I could bring up a lot of these devices here for you guys to try, but they can talk about it, collaborate in the same space. If they don't have a HoloLens, they can also contribute from sort of a desktop mode. We can step through sort of animations. So imagine this could be super useful building like IKEA furniture, or building out a party space or architecture. But in our case, of course, it's designing spacecraft. You can do things you can't do in the physical world. You can stick your head through objects. You can, you know, take physical objects and compare them into real life. So when we get our assembly mechanical engineers in here, they walk through it, they put their real cables and the real tools and wrenches to see if they can actually build this thing, right? And so it's a really powerful, engaging experience. And that's all I had for today. Do you guys have any questions about some of our VR AR work? We haven't done overlays yet. That's one of the requests we've received. Some of the next steps we're really interested in is authoring. So all of these tools right now, they're more on the visualization side. So you've got all this complex data. The first step is to see it, right, in this immersive world. The next step is to do something with that data. And so authoring it, being able to edit it in situ, being able to mark it up and save it and share it, these are some important next steps. And then I think the thing after that would be, you know, analysis of the data autonomously, like looking at key targets and being able to quickly point out potential errors or faults or particular areas of interest. These could be all interesting future topics to explore. Any other questions? Yeah.
So like clearly you guys have like overcome like a ton of barriers when it comes to designing things, and especially for like spacecrafts. What do you think would be like the next step or like the next hurdle to jump over? Like just like visualizing things like in real time, so you just did with the HoloLens.
Yeah, I mean, the goal of all of these projects is really to make the technology disappear, right? We want, I mean, like I mentioned before, our scientists, our engineers, our astronauts, they're not technology experts. Some of them have just mastered the smartphone. So telling them that, hey, like you gotta set up this crazy VR rig and put on this headset where you can't see anything is really scary for them. So eventually, I think we're going to get to the point where, they're putting on their AR glasses the same way they're putting on their safety glasses, right? And getting to the point where they're comfortable using it as an everyday tool, just like their cell phones. So that's kind of the next obstacle we have to tackle simultaneously, in addition to our technical hurdles, is this barrier of entry, right? Making it as easy as possible to accommodate as wide of an audience. And working in conjunction also to make sure that this data set is available to everyone else, right? Like some of the cool stuff with Mars, these spacecrafts, it'd be great if we can open source some of this stuff so everyone, right, students, classrooms, museums, teachers everywhere can start building experiences using these assets. And we're working on making that available too. Yeah. Yeah, so we use every single headset. They all have their pros and cons, right? Some have better input, some have better field of view, some have better tracking solutions. And there's constantly new stuff that's coming out. Some things are announced, some things that aren't announced. So I think as a technology group, we're constantly on the prowl for what's the next best thing. And the best thing is subjective, right? It's the best thing for solving a particular problem. And so some of these problems are building spacecraft, some of these problems are helping astronauts, some of these problems are something completely different. And for example, like exploring exoplanets or different new worlds, right? Being able to visualize what it would mean to land on a moon of Jupiter, or to grab an asteroid and bring it back to moon orbit. There's some big challenges ahead for us. And to think about the technology it would take to do that and the type of visualization it would take to help these engineers is sort of an ongoing, conversation. Yeah. Mm-hmm. Yeah, that's great question. A lot of people think, at JPL and NASA, we only hire like aerospace engineers or systems engineers or mechanical engineers. It's a clear connection, right? But as you can see here, Lois and I are neither of the above. I'm a software engineer and she's a designer. And I think I would challenge people to kind of open their minds and think about how they can contribute to some of these problems, as opposed to what category or box they're trying to fit themselves into. So specifically on our teams, we hire everything from developers, of course, to mechanical engineers, to user interface, user experience designers, to human factors researchers, to producers, systems engineers, and sort of everything in between. Right? There's a lot of problems that we have to solve, and it takes more than one discipline to solve any one of these problems. And that's why we're always super eager to work with commercial partners as well as academic institutions such as yourself. Any other questions for me or Lois? All right. Well, thanks for coming, guys. We'll stay around for any other follow-ups. Thanks.